Hello, my dear students and the rest of the learners. Welcome to part 21 of a 29-part series of tutorials in Fundamentals of Structured Programming using C. In this presentation, we are going to look at the introduction to arrays with our focus being on one-dimensional array. My name is Meme JM, so you can simply call me Emily Swap. Let's begin by looking at the introduction to arrays. An array is a data structure which contains data that is of the same type, but it is a data structure. So, what is a data structure? A data structure is a logical model of how data is organized in main memory. Therefore, an array data structure is said to be a group of memory locations that stores a list of data values of the same type and with the same name. This simply means that if you organize data of the same type and the same memory location with the same name, that is what we call an array. And therefore, we are saying that an array is that data structure which is composed of memory locations that stores a list of data values of the same type and with the same name. If the type changes, for example, if you have data of mixed type, like numbers and text, for example, the name of a person and his or her age, for example, Julius 90, that is not an array. An array, we are saying, is composed of data of the same data type. If it is integer, it is integer. If it is text, it is text. So an array is composed of data of the same type. For example, 20, 40, 35, 3, 6. That is an array. If you have data like, for example, for names such as Julius, Jane, Otieno, Kamau, Salati. When these names are stored together in the memory locations, then that is also an array of that specific type. Therefore, you can also say that an array is a list of values, but list of values of the same type. Now, the list of data values that are found in an array are called the array elements. The syntax for declaring arrays is as follows. In other words, this is what we're supposed to do to inform the compiler or the processor that what you are requesting for is for the processor to set aside an array. You begin with the data type, followed by the array name, and then in the square brackets, you enclose what we call the number of dimensions or subscript. An example of an array and how we declare is following shortly. Therefore, an array declaration indicates the data type of each element, the name of the memory locations to be occupied by the array, and the number of elements required by each array. However, it is the number of dimensions or subscript that an array has that makes one distinguish between the various types of arrays. For example, a one-dimensional array has a single subscript as, for example, size. So you enclose a specific number, a single number, within the pair of square brackets. A two-dimensional array has two subscripts indicated as, for example, the first subscript X and the second subscript Y. For example, if you have a 2 by 3 dimensional array, you enclose 2 in the first square brackets, pair of square brackets, and 3 in the second pair of square brackets. So it would be 2 in the first square bracket and 3 in the second. A 3-dimensional array, on the other hand, has 3 subscripts organized as x, y, and z. X in square brackets, y in square brackets, and z in square brackets as indicated. And if you have 4-dimensional arrays, you follow the same style. Therefore, the 2 main types of arrays are the 1-dimensional array and multi-dimensional arrays. Let's begin by looking at what we call 1-dimensional array, which will also be the focus of our presentation. A 1-dimensional array is an array composed of only one row, but with many columns, or many rows and one column. It is also called a vector, and it is declared using the format that I've already indicated as data type, followed by the name of the array and its size or its number of subscripts. If, for example, a student has scored 10 scores as follows: 45, 90, 20, 53, 100, 15, 78, 34, 11, and 60, meaning that these are scores attained by a student either in the same subject but several exams, or these can be scores of 10 examinations taken by the candidate. Then, if you write it, for example, as scores, so scores becomes the name of the array, while the 10 scores become the array elements. So this will become an array if you are requesting the processor to set aside memory location that is going to accommodate 10 values of type integer. The data type for this array will be of type integer, that is int. Because this list is composed of whole numbers, its name will be scores, and its total number of elements, that is the array size, will be 10. We shall therefore declare this array as follows. First is the data type. So the type of data are whole numbers, and therefore the data type is int. The name of the memory location that we want the processor set aside to accommodate those 10 values is scores. And then the number of array elements that we need are 10. And therefore, you declare it as int scores. And then when you close 10 in square brackets, and you terminate that declaration with a semicolon. The elements in an array are identified using their positions in memory. That is what we call the index, which are numbered from index 0. So the first element in the array will always be identified with index subscript 0, or the second one will be identified by index subscript 1. The third is index subscript 2, and the same continues, and therefore it means that the last element, that is the 10th element, will be identified by index subscript 9, because the first one is 0. Therefore, to identify the index for an element, you pick its physical number and subtract 1 from it. For example, the physical position for value 45 in the array is 1. That is, if you go back to our array, this is our array, you can see that we have the first element being 45. So instead of writing this index as 1, it is 1 minus 1. So it is 0. So the index for the first element is 0. So it is identified by the use of subscript 0, that is scores, and then when you close 0 in square brackets. If, for example, we pick value 100, 100 is the fifth element. So this one will be identified in the subscript 4 because it is element number 5. So it is 5 minus 1, which gives 0, which gives a 4. I repeat, value 100 in this array is the fifth element. So the fifth element, which is at position 5, will be identified by index subscript 4. The reason being, it is 5, that is position 5, minus 1, which will give 4. If we pick the last value, value 60, this is the 10th element. It is at position number 10 in the array, and therefore its subscript will be 10 minus 1, which is 9, and therefore it is scores, and then when you close subscript number 9 in the square brackets. So that's how we make use of the index for identification. Therefore, to identify the index of an element, you pick its physical number and subtract 1 from it. And that's why we are saying that the physical position for value 45 in the array scores is 1, and therefore the index for it will be 1 minus 1, which gives 0. Therefore, 45 will be accessed by the compiler as scores 0. And remember that the name of the array, if it begins with uppercase, scores S, and another one begins with scores, but the first letter being small letter or lowercase s, those will be two different types of arrays because C is case sensitive. The physical location for 100, as we have seen, is 5, and thus its index is 5 minus 1, which is 4. It will thus be identified by the compiler as scores enclosed with or subscript 4 enclosed in square brackets. Therefore, the physical location and the index for the elements in the array called scores can be represented as follows. So we have the physical position 1, 2, 3, 4, 5, up to the 10th position, where we have 45 as number 1, 90 as second, 20 as third, 53 as the fourth, 100 as the fifth, 15 as the sixth, 78 as the seventh, 34 as the eighth, 11 as the ninth, and 60 as the 10th. So we have the elements 45 all the way to 60, spanning from physical position 1, position 10. However, when it comes to index, we have said it is the physical position minus 1 get the index. So the physical position 1 for element 45 will be identified by the compiler as 0, that is 1 minus 1 giving 0. 78, which is the 70th position, will be identified by index 6, because that is 7 minus 1, which gives 6. And therefore, the difference between the physical position and the index is -1 or -1. You subtract 1. If it is position 2, index 1. Position 8, index 7. Position 4, index 3. Position 10, index 9. Once you are able to identify an element using the array's name and index, we can then manipulate the elements just as if they were ordinary variables. For example, you can replace value 20 in the array with 18 by writing it, for example, as scores, then subscript 2 equals to 18. When you write the scores and you enclose subscript 2, it's important you note what we mean. You can see that 20 is position number 3, but its index is 2. So if you want to replace value 20 with value 18, we just need to write it as scores. We enclose index 2 in the square bracket, and then we have the assignment operator, and we write 18. So that's how we can do the replacement, or that's how we assign values into specific positions in the array. If we want to add, for example, value 100 and value 60, that means value 100 in the array and value 60 in the array, and assign the results, for example, at the first position in the array, you do it as follows. Remember, the first position where you want to assign the value is index 0, and the name of the array which contains value 160 is scores. So you write it as follows. Scores 0 equals to scores 4 plus scores 9. Why? The reason is because 60 is the 10th element in the array, but its index is 9. So 60 is identified with the use of the name of the array scores and subscript or index 9. So when you write scores 9, we are referring to 60. So this statement can be read as 60 plus 100 equals to, we assign the total, which is 160 in the first position, which will be 160. So as you can see, my dear students and the rest of the learners, we simply identify values using, or elements of the array, using the array's name, the specific index for that array or for that element. And therefore, we can perform any operation on the elements of the array as long as you make use of the appropriate name of the array, the appropriate index. To multiply, for example, the 8th element in the array by 2 and assign the results in a variable which is outside of the array, for example, called results, we can do it as follows. So this statement, my dear students and the rest of the learners, simply means you are telling the compiler or the processor to go to the memory location which contains the array called by the name scores. So go to the memory location called scores and go to the 8th element. Go to the 8th element, which is identified by subscript 7. And then multiply that value that you pick by 2. So if the 8th element in the array, for example, let's go there. As you can see here, the 8th element of this array is 34. It is 34, whose index is 7. So if you want to multiply 7, or if you want to multiply 34 by 2, if you want to have that 4 multiplied by 2 to get 68, what we just need to do is to write scores 7, that is index 7, scores 7 times 2. That is like saying 34 times 2. So that's what we mean. To assign all the elements into the array, we would use a declaration statement that initializes the array as follows. In other words, if you have declared an array, you have requested the processor to set aside memory location to hold an array or a set of, or a list of elements of the same type, but in memory location with the same name, we can do it as follows, or we can assign the following values into that array all at once using a statement like this. First of all is the data type for the array, which is int. The name of the array is scores. Now, instead of telling the processor the specific number of array elements that we are going to assign into it, we leave it without the figure or the number, mostly when you are initializing it. And then you have the opening brace and you list your elements in the order in which you want them to be placed in the array. And you enclose them in the closing brace and then a semicolon. So what this statement simply means is that you are telling the processor to set the memory location assigned to hold an array or a list of elements of the same type, that is like integer, and that memory location will be initialized with the following values in the following order: 45, 90, 20, 53, 100, 15, 78, 34, 11, and 60. So 45 will be the first element in the array called scores, while 60 will be the 10th element in the array called scores. And therefore, this array spans from index number 0 to index number 9. Or you can also have it as follows. There's nothing wrong with that writing the number of elements that that array is going to hold or accommodate. So you can have it as int scores. You enclose 10. 10 in this case indicates the number of elements that will be in that array. And then you have equal sign or assignment operator, opening brace, and then you list the elements in the order or in their order, and then you have the closing brace and a semicolon. Therefore, you can assign 10 values for scores into memory as an array and manipulate it as you want by ensuring that you make use of either code in a program that initializes the array during declaration, or you can write a program that allows the user to enter the array elements through the keyboard. In other words, my dear students and the rest of the learners, we are saying that there are two ways or two methods of assigning elements into an array. The first method is where you don't want the user to determine the specific elements to be in the array. And in that case, you need to initialize, that is, declare the array and initialize that array within the code during coding time. The second method is where you just request the processor to set memory location assigned to hold an array or a list of elements of the same type, and that memory location will give it the same name, and then the user can be requested to key in the values that he or she would like to be in the array during the processing of a program. So the user will enter values through the keyboard. To manipulate the elements of an array, we make use of an iterative statement such as for loop for each dimension. In other words, because an array contains a number of elements, if you want to carry out a certain operation among those elements, it means that you have to repeat the process as you handle each element at a time. If, for example, you have 10 elements and you want to compute their sum, it simply means that you have to go to the first element, then go to the second element, and the value of the first, or add the first element to the second element. Then go again to the third value, pick that value, add it to the total gotten, and continue up to the end. So in this case, it means that we repeat, we perform, or we carry out certain repetition when performing an operation that spans from one element to the next element in the array all the way to the last element. And that's why we are saying that it's always good to make use of an iterative statement when you're handling the array elements. And such an iterative statement would be the for loop. The following is therefore a program implementing one-dimensional array to initialize the array called scores with the following elements at declaration time. Then we compute the total of the array or for the array and display those array elements together with their total on the screen. The name of our array is scores, and our elements are 45, 90, 20, 53, 100, 15, 78, 34, 11, and 60. So this is how our program will look like. One of the first thing we need to do, as usual, is to have the comment for our program. So this comment or our comment is computing sum for a one-dimensional array. We have our preprocessor directive there. We have our main there. That is main function. And then we declare the array. So this statement is declaring the array and initializing the array with all the elements. So this is how we read this statement. This statement tells the processor the following. Set a memory location aside called discourse that is going to accommodate 10 elements, and those elements will be of type integer. Then assign into 8 the following elements: 45, 90, 20, 53, 100, 15, 78, 34, 11, and 60 in that order. That is from element, subscript, index, or index number 0 to index number 9. The next is we are requesting the processor to set two memory locations aside, two variables. One called sum and the other one called index, both of type integer. Then the next comment is computing the sum for the elements. So this section of code is going to be used to add the sum or to compute the sum of the elements that are in our array. So we have computing the sum for the elements as our comment. Then we initialize the memory location called the sum for the variable called the sum with 0. Then we have our for loop here. Remember, we are going to be adding first element to the second element. We get sum, we add the third element to the sum, we get an answer. We add the fourth, we add the fifth, all the way. So we are going to be repeating. That's why we have the for loop. So this is how our for loop will work. So it is for, then we are initializing the memory location of the variable called index with 0. Then we check whether the value of index is less than 10. So in our case, we have 0. So is 0 less than 10? Yes. If that is true, we enter into this. If we enter into the loop and do the following, we request the processor, or the processor goes to the memory location called scores, that is in the array, and accesses the element with index subscript or subscript 0. Remember, we have already initialized our index with 0. So the first element in the variable called index as it stands is 0. We have checked whether the content of that memory location is less than 10. And we have seen it is true. 0 is less than 10. So the next activity that we need to do is to compute sum. And how do we compute sum? We are telling the processor, go to the array called scores at index or subscript 0 at subscript 0. So scores 0. So scores 0 contains value 45. So get 45 added to the current content of memory location called the sum. The current content of memory location called the sum is 0. So it simply means that what we are doing is that we are getting value 45, we add it to 0, and the results that we're going to get, we store them in the memory location called sum. Once that is done, and this breeze is encountered, the processor goes to the last part of this for loop, which is incrementing index with 1. That is index plus plus. That is index followed by the increment operator. So what that means is that we are telling the processor to get what is the value, the current value in the memory location called index. We add 1 to 8, and then we assign the results back to the memory location called index. So this statement simply means the last bit of this for loop statement means that we are having it as a 0 plus 1, which is 1, and then that 1 is reassigned back to index, or the memory location called index. And then from there, so it means that currently the value of index is 1. We then check, is the value of index less than 10? Yes, it is. So because index contains 1, 1 is less than 10. So we perform the following operation again. Pick the value at the array or in the array at position number index 1. So that is scores 1. So scores 1, 1 is the index. So scores 1 is 90. So what that means is that we are telling the processor to pick value 90 and it is the current content of sum. And you have seen that the current content of sum will now be 45. So it is 90 plus 45. And the value or the answer you are going to get, we store it in the memory location called sum. So 45 plus 90 will be 135. And that 135 will be stored in the memory location called sum. Once this brace is an countant, the processor will move to the end of this statement, increment the current value of index, and that will continue, or the process will continue until when all the elements have been added. So let's, for example, do something here. Let me show you how it will be behaving. So the first item here, we have initialized index to 0. So it means that we have value 0 here. So is 0 less than 10? Yes. So we read, we tell the processor to go to the memory location called scores, or to the array called scores, and read the element which is represented by this statement, score 0. So score 0 is this element here. Remember, these elements are 0, 1, 2, 3. These are the index. These are the index for each of these elements. 6, 7, 8, 9. So scores is the name of this array. So scores 0 is 45. So we are picking 45. We are picking 45 here, the first element. We are adding to current content of memory location called sum, which is 0. So it simply means that we have 45 plus 0. And then the answer we get, we assign it back to the memory location called sum. So in the sum, we have first route 45. And then once this is an countant, we increment the current value of index. The current value of index is 0. So here is 0 plus 1. And then we assign the value back to index, so that will be 1. And then we check here. Is 1 less than 10? Yes. So we repeat this activity here. But this one changes to 1. So scores 1 is this one, is 90. So that will be 90. And then plus what is in the sum? The current content of sum is 45. So it is 90 plus 45, which gives 135. So 135 is assigned back to sum. It's stored in sum. So that means we have a 135 there. And then once this is an countant, we increment the value of index. So that is plus 1. 0, 1 plus 1 becomes 2. So our current value of index is 2. So is 2 less than 10? Yes. So we repeat this activity. Remember, this is 0, this is 1, this is 2. This is index. This is index. So we go to the array and pick the element whose index is 2. So scores 2. Scores 2 is 20. Scores 2 is 20. So this is like saying 20 plus the current content of sum. The current content of sum is 35. so plus 20. This will give us 155. And then this 155 will be stored in back to sum. And then we move to the last bit of this index. We increment the current content of index with 1. So it is 2 plus 1, which gives 3. Then we check, is 3 less than 10? Yes. So we repeat this activity, and that will continue till when the last element will be element or index, until when the last index will be 9. So when index is 9 less than 10? Yes. So the operation will continue. And then once the index moves to index number 10, once 9 or index is incremented with 1, that is 9 is incremented with 1, it becomes 10. So we check, is 10. We now check, is 10 less than 10? No. So we are going to skip this loop and come out. So my dear students and the rest of the learners, that's how the for loop works. If you don't understand or you wonder how the for loop is working, kindly go through the series of tutorials that we have been learning, and especially on loops, and study on iterative structures. There is a video that is already posted in the Melisop ICT YouTube channel that is explaining about loops and giving a demonstration. So you can go there and learn more about for loop. And once you understand how for loop works, it will be very easy for you to also understand how for loop works when it comes to manipulating the elements of an array. So once that is done, we can then display the array elements. So this statement tells the processor to display the following statement on the screen. This array called scores contains the following elements. So this statement will be displayed on the screen. And then this statement here is simply helping the user to be able to see or to know that the elements we are about to display are the elements from an array called the scores, whose total number of elements are 10. So what will be written out on the screen will be the one scores, then square bracket, 10 square bracket equals 2, followed by the opening brace. Then from there, this other statement is for helping us go through each of the elements one at a time. So we initialize index to 0. So then next we check, is 0 less than 10? Yes. If it is true, we write the following, or we display the following on the screen. We go to the array called scores index 0. So scores index 0 will give us the first element. So we pick that element and then we write it, or the processor will pick that element and write it on the screen from 10 to 5 characters, or in other words, 5 spaces. So once that value is written on the screen, and this is an accountant, the processor will go and go to the last part of this loop, that is index plus plus, or it will increment the current value of index with 1. So 0 plus 1 is 1. Is 1 less than 10? Yes. So we are going to read, or the processor will go to the array and read the element whose identification is scores 1, the index 1. That will be the second element. It will be displayed on the screen from 10 to 5 spaces. And that will continue. That will continue. The reading will continue until the value of index is no longer less than 10, and then the loop will end. And that will mean that all the elements will be displayed on the screen. Then this brace will be written on the screen, followed by this statement, whose total is. So the processor will go to the memory location called sum, read the value in sum, memory location called sum, and display it on the screen. And of course, The content of this memory location called sum will be the total of the array elements. That is the total of the elements in the array called scores. And once that is done, this statement is telling the compiler or the processor to take the control back to the operating system, and then the program will end. So the output for this program will look as follows. That's how it will look. This array called scores contains the following elements: scores 10, and then the elements are there. So let's write this program, or the above program can also be coded as follows. In other words, my dear students and the rest of the learners, instead of initializing the array with the elements, you can also allow the user to key in the elements himself or herself through the keyboard. So what we just do to this program is just to change this part here. Instead of initializing the array, we just tell the compiler or the processor, set memory location aside to hold 10 elements, and the name of that or those memory locations will be scores. So in other words, this statement is telling the processor, set aside memory location that will be able to hold or accommodate 10 elements of the same type, that is of type integer. So no initializing. And then from there, we just now, from the user, enter the values. So this statement is going to be, this statement is displaying the index number, and then here we have the value, reading of the value. So when the user enters a value, the value will be read, and it will be stored in the array at the appropriate position, and then the processor will increment the current value of index, check if the value in the index is less than 10. If it is less than 10, this statement will display the next index, and then the user will key in a value, and that will continue until when the value of index is not less than 10, when this loop will be terminated, and the next statement will be executed. So the next statement to be executed is this one. So this statement is initializing sum with 0. And then from there, we have another loop here, the for loop, which is now going to do the addition. So this is what or how it will work. First of all, we are initializing the current value of index or memory location called index with 0. Then we check, is 0 less than 10? If that is true, of course that is true, 0 is less than 10, the processor will enter in this loop and do the following. It will pick it will go to the memory location called scores at index number 0, so scores 0. So it will go there and pick that element which is there, and then add that value to the current content of memory location called the sum. And of course, we know because this is first round, the current content of memory location called the sum is 0. So it will pick the value of the first element in the array and it to 0. And the results which will be gotten will be reassigned back to the memory location called sum. Then once this base is encountered, the processor will go to the last part of this statement. That is the statement which is telling it to increment the current value of index with 1. So it will be 0 plus 1, which becomes 1. Then we check, is 1 less than 10? Yes. So if 1 is less than 10, the processor will go to the memory location called scores at index number 1. Pick the value which is there, then add that value, the current content of memory location called sum. And the results which will be gotten will be assigned to the memory location called sum. Once this base is encountered, the processor will then increment the value of index with 1. So if it was 1, the current value will be 1 plus 1, which gives 2. So is 2 less than 10? Yes. So it will go and pick the value at index number 2, which is the third element. Then add that value to the current content of memory location called sum. And that will continue until when the value of index will be 10. When it finds out that 10 is not less than 10, it will skip this for loop. By then, all the elements will have been added, and it is just stored in sum. Then the next statement is to display the array elements. So this statement will be displayed on the screen. This array called scores contains the following element. Then from there, we write the name of the array and the closing 10 in subscript. Once these characters are displayed as they are, the next part is to have the for loop, which will be used to do the printing. It will go when index is 0. When index is 0, it will pick the first element in the array at its scores 0, that is that index, and write it on the screen. Then increment the value of index with 1. Check if the value of index is less than 10. If that is true, it will go and pick the second value with the next index, which is index number 1, and display it on the screen. And that will continue until all the elements have been printed on the screen. And then this base will be written on the screen. And at the end, we are going to have whose total is. The ones whose total is will be displayed on the screen, and the processor will pick the current content of memory location called the sum and write it on the screen. And that will be the end. So this statement tells the compiler to return the control back to the operating system, or it tells the processor to return the control back to the operating system, and the program will end. So let us now code this program that we have discussed using Falcon IDE so that you can see how it will behave when executed. So my dear students and the rest of the learners, what we want to do now is to start Falcon IDE, and then we are going to code this program. We are going to code this program, and then we see how it will behave. This is the program that we are going to code. You can also practice, my dear students and the rest of the learners, you can also practice with this program. So you can code this program in your computer, that is using Falcon IDE or any other IDE for C, and then see whether it will behave as I have already explained, and you see whether it will give this your results or your output as displayed on my screen here. Otherwise, the program that we are going to code is this one, which allows the user to specify his or a specific element, do the computation, and display the results on the screen. So my dear students and the rest of the learners, you can copy this program in your Access book or in a Avanti processor, then type them in Falcon IDE, save them, save it, compile it, and run it to see how it is going to work. And that's exactly what I want us to do. So let's begin by loading Falcon IDE. So let's load our Falcon IDE. So in your computer, my dear students and the rest of the learners, search for Falcon or load Falcon IDE, just as you have been doing before, or any other IDE of your choice, but I would prefer you make use of Falcon. Then click on File, point on New, and click on Project. Add a new project, click on Empty Project, and click Next. And the project name, give it a name, so I'll call it One Dimensional Array. The compiler is type C. Then we can click on Finish. We can then right-click on New. That is, we right-click on the name of our project. Because we want to create our file, point on New, and click on C File. On the proposed name, change it so that it reflects the purpose or the function of our program. So we are going to rename it, and I'll call it one-dimensional array. And then you click on it and do the typing of your program here. So the program that you're going to type is this program. So this is the program that we are going to type. If you have written it, for example, using word processor, you can just copy it and paste it in your IDE. So that is the program. So write it slowly. First of all, write it in your exercise book and then code it in the IDE. So let's see how this program is going to behave in our Falcon IDE or using Falcon IDE. So in our case, we are going to paste our program here. So just click on the name of your file or program and paste your code. So this is our program, which you can type. You can see this is our comment. Preprocessor directive is here. Then we have int main, and then we have declared our array here the same way that I have explained. Then we have our variables there. We have this for loop for reading the values. And you can always indent it nicely. Always ensure that your program is well indented. So let's indent it that way. Then we have this section for doing the computation, computing the value or the sum of our array elements. And then the next is we have the section for displaying those array elements on the screen, as well as displaying the total of our array on the screen. So this is our program. We can now save it. It's always good to click on Save All so that you save the project together with the file. And you are supposed to browse where you want to save your file as well as your project. Once you save your project, your files will also be saved in the same location or place. Give your file a name. My name is one-dimensional array. Then click on Save. So that's our program. Let's now compile it so that you can see if it has any errors, and if there are any errors, we debug. So we are going to click on Run, then we click on Compile. Remember, from the beginning, early in the series, we said, or we explained the purpose of compiling, and we said that compiling is simply the process of converting the source code into object code so that it can be able to be executed by the machine. But if your program has any errors, the conversion will not take place until you debug or rectify those errors. So as you can see, our program has no errors, and therefore our compilation is successful, as you can see at the bottom here. So what we are going to do next is to run our program. So to execute or to run the program is to tell the compiler or tell the processor to do as our program as instructed. So we are going to click on Run, then Run. So this is our program. You can see it is already executing. The first statement is this one here, which is the very first statement. in our main program. That is, enter 10 values in the array called scores, and you can see that we have the first one, which is score 1. So let's enter some elements in this array as we press enter. So type 45, that is 45. You can see this is now looping. It is looping, incrementing the current value of index. So where it reads score 1, 1 is the index. So after entering the value 45, the processor has incremented the value of index with 1. So 1 plus plus, that is 2. So the second index is 2. That means the second element. So score 1. Now, let me repeat something here, my dear students and the rest of the learners. What I'm displaying as score 1, score 2 are simply the positions, not the index. It is the position. For example, 45 is position number 1, so it is score 1, score number 1. It is score number 1. So after entering 45, the process incremented it with 1, so the next one is score number 2. So we can type our scores or our values, and we are going to type all our values up the last value. You can see this is score 10. And if you check carefully, the for loop for reading the values, you can see that once the value of index is more than 10, the program or the loop is supposed to terminate. And in our case, we are entering 10 values, and therefore we don't expect this program to allow the 11th score. So once I press enter, we are going to see the results. The reason being, once I press enter, the processor will move on to the next loop or the next statement. It will exit the loop for reading the values, then go to the next statement, which is initializing sum with 0, and then computing the scores. So the scores I have entered will be computed very fast using the computing the sum for the elements for loop. And then, because that will be done very fast, the next thing that we're going to see is that the statement which will be displayed on the screen is that this array called scores contains the following elements. So my elements will be displayed on the screen, followed by the statement for the total. So once I press enter now, we expect to see the results. So let me press enter so that we see what happens. You can see. If you look, you can see that our next statement after entering the last score is this array called scores contains the following elements. And you can see the way I have formatted it. We have scores 10 equals, and then we have our elements there. If you check carefully, these are the elements in the order I entered them. You can see from the screen that the first element from the screen is 45. And 45 is the first element there. The second element entered all the way to the last element here. So my elements as entered, these elements have been displayed in the same order. So my dear students and the rest of the learners, it is important for you to know how to enter elements into an array, how to compute those elements, how to perform any operation with those elements, and even how to display them, and even how to do things or operations like computing sum, multiplication, etc. So let's press enter. Let me press any key to continue. So my dear students and the rest of the learners, that is how we write a program for computing a one-dimensional array or a program for working with one-dimensional array, and that's how it works. Let's save our work, and then we close all our files. We exit from our IDE, and that marks the end of part 21 of the series, in which we have learned about introduction to arrays and one-dimensional array. You can now proceed to part 22 of 29, in which we are going to learn about multidimensional arrays. Congratulations for learning part 21 of 29 on Introduction to One-Dimensional Arrays in Fundamentals of Structured Programming using C. You can access the rest of the parts in the series, as well as other computer or ICT videos by clicking or tapping on EmeliSwap ICT YouTube channel below this video. To subscribe to the channel, tap on subscribe button below this video in YouTube if it's not currently reading as subscribed. For any further correspondence, kindly write it to us through the email emeliswap@gmail.com. Thank you very much for listening to me. Let's meet in part 22 of the series. And God bless.